Today, I will do a video presentation for my course project in Data Communications and Networking 1. So, in this course project, the objectives of this activity is will assess your knowledge and skills in applying land technologies and network services required by converged applications in a small scale or local network. So, the part one is create a video presentation from the topics listed below. Select one group of topics only. The video must include an introduction, discussion of the topic, and sample configurations using Cisco Packet Tracer for each topic. The video should include yourself presenting the topics. For the visual content, the student may use different materials and style. Example, PowerPoint, live discussion, paper discussion. So note, make sure that your face is clearly seen on the video as well as the display on the screen. So as you can see, my face is here on the right side. So here is the list of the topics. So in group 1, networking fundamentals, network types and topologies, and network models. In group 2, physical and data link layer, network layer, and transport layer. And group 3, session layer, presentation layer, and application layer. So in this list of topics, I choose the group 1, which is network fundamentals, network types and topologies, and network models. So I prepare my presentation. So it is here. So here in the course project. So I'm just checking. This is my face. So I'm still clearly seen. So let's start the presentation. So course project, data communications and networking 1. So the first topic is networking fundamentals. So in this topic, we will discuss about computer networks, components of the network, presentation of network devices or components, and application that uses a network. So, computer networks. A computer networks is a set of computers connected together for the purpose of sharing resources. It is a collection of computing devices that are connected in various ways in order to communicate using electronic means. Connections between computers in a network are made using physical wires or cables, but through network connection. Computers are able to share file, internet access, printers, or etc. But nowadays, it can be connected using wireless means using radio waves or infrared signal. So, components of the network. So, the computers are connected through either the use Ethernet cables, sorry, or through wireless connection. Devices like routers, hubs, and switches make it possible. So, and devices, hardware components. So these are the computing device that interconnects which has an IP address that is unique for every computing device such as laptops, personal computers, printers, workstations, smartphones, IP cameras, and etc. So this is the visual of this said end device. So we have here laptop, personal computer, workstation, smartphone, printers, and IP cameras. So, intermediary devices. These devices provide connectivity to the network, connect individual networks, and connect segments within the same network. So, the samples of this is network access devices such as hubs, switches, and wireless access point, internet working devices such as routers, communication servers and modems, and security devices such as firewalls. So here, the network access device is this is hubs, switch, and wireless access point. For internet working devices, this is a router, communication servers and modems. So this is the servers and this is the modem. So and for security devices, such as firewalls. So here, this is the firewalls. So hubs. What's hub? So hub, this is a device connecting multiple computers together and makes them perform the function as a single unit. So switches, this is a networking device that connects devices together on a computer network. And routers, these are small electronic devices that join multiple computer networks together via either wired or wireless connections. And network card. Network cards, also known as network interface cards or an NICS, are hardware devices that connect a computer with the networks. So modems, this is a device or program that enables a computer to transmit data over, for example, telephone or cable lines. So representation of network devices components. In computer networking, a series of standard symbols or images are used to represent different network devices and components. So as you can see down, are the common data network symbols. We have here router, wireless router, bridge, switch, hub, wireless access, wireless bridge, wireless link, laptop repeater, gigabit switch, serial link, serial DCE, token ring, copper, crossover, phone, modem, firewall, internet or cloud, or and IP phone. So, what are the applications that uses a network? So, we have games, allows multiplayer games between various devices. We have also databases. Networking makes it possible for different computers to access the same database. Email, sending and receiving emails is one of the important functions of network. Video conferencing. So in video conferencing, applications such as WebEx, FaceTime, and Skype is possible because computer networks. And then we have also file transfer protocol, stand for FTP. Exchanging files over the web mainly uses network connection. So we done already on the first topic. So now we will go to the second topic, which is network types and topologies. So in this lesson, we will learn about the three basic types of network, which is LAN, MAN, and WAN, and server client model, network design and topology, network protocols and communications. So let's start with three basic types of network. So here we have local area network or LAN. This is an individual network that usually spans a single geographic area, providing services and applications to people within a common organizational structure, such as single business, campus, or region. Common LAN devices are switches, hubs, and routers. So here down you can see the image of LAN connection. Have laptops and devices here and switches, routers, and printers that represent a local area network. Next is wide area network or WAN. A network connection between two or more LAN over a potentially large geographic distance. Often, one particular node on a LAN is a setup to serve as a gateway to handle all communication going between that LAN and other networks. Communication between networks is called internetworking. The internet is the best example of a WAN. So here I have also a visual of WAN connection. And lastly, Metropolitan Area Network or MAN. A MAN usually interconnects a number of LANs using a high capacity backbone technology, such as fiber optical links, and provides uplink services to ones and the internet. A man's coverage can span between cities. So here, this is the image of Man Metropolitan Area Network. So here, there's land and there's a building also, internet. So it's connected in different area. So we'll go in the next topic. So which is server client model. So servers have software installed that enables them to provide information and services like email or web pages to other hosts on the network. Clients have software installed that enables them to request and display the information obtained from the server. The relationship between clients and servers is known as the client server model. In a computer network, a server is a computer that provides services to other computers, known as client. A client host can be either a computer hardware or software that accesses a service from a server. So here we have a visual of a server client model. So here is the clients. So they are connected with the internet and then the server. So network design or topology. So, what is network topology or design? A network topology or design is the arrangement of the computers in a network. So here down, you can see the types of network topology. We have bus topology, ring topology, star topology, mesh topology, hybrid topology, and tree topology. So what are these and what are the function of this topology? So let's start with bus topology. So bus topology is a network topology in which every computer and network device is connected to a single cable, which is like this. Later, after I finish this, I will do the actual design in Cisco Packet Tracer. So ring topology, this is a topology that forms a ring as each computer is connected to another computer, with the last one connected to the first. Next is star topology. This is a type of topology that all the computers are connected to a single hub through a cable. Then mesh topology is a type of network topology in which all devices in the network are interconnected. So it's like this. And hybrid topology, it is the combination of two or more different topologies. So which means that you can do or two or more different topologies like this. This is a star topology and connected with bus topology and ring topology. And we also have tree topology. So tree topology is a special type of structure where many connected elements are arranged like the branches of a tree. So like this. So it's like a branches of a tree. It's form a figure of branches of a tree. So before we go on in the next topic, I will show you how I will do it in Cisco Packet Tracer. So now, as you can see, we are in the Cisco Packet Tracer. So at first, we will do the bus topology. So I will be needed a PC and device, which is the end device, and then a switch. another switch here. So here we will connect it in this line, line. So you can use automatic choose connection type or this copper straight through. But for the faster presentation, I will use the automatic. So just this one. I will connect the PC to switch. And then I will connect all the switches to each other. So as you can see, when you connect a switch to switch, the cable or the medium that we will use is this one, which is the copper crossover. Okay, so there you go. We have already our bus topology. So next, we will do the ring topology. So again, we will put a device in device and switch. And then we will connect it. Okay, so this is the ring topology. So as you can see, it's formed as a circle and it's connected to one point to another until the last. So next we will do the star topology. So in star topology is connected with all devices is connected with one intermediary device only. So we will use a hub. So now we will connect this to hub. All of this end device we will connect it to hub. So there you go. We have already our star topology. So next is mesh topology. So again, we will put our end devices here and devices here and devices here and devices here and then a switch. Switch here, switch here, switch here, and here. So how we will do it to become a mesh topology. So as you can see, it's like similar to ring topology, but the difference is, I will show you how. So let's connect it first. Okay. So as you can see, it looks like a ring topology, but how it will make a mesh topology is I need to connect the other device, other switch crossover, and this one here. So there you go. We have already our mesh topology. So we will move on to hybrid topology. Just one thing also, maybe you will notice that there's a green lights here because before it's like this, it's color orange. So this color orange, it means that it's ongoing connection. So when it turns to green, it means that the connection is successful or the connection is good. So moving on, we will do the hybrid topology. So hybrid topology is a combination of two or more types of topology. So first, I will do a ring topology. And connect it all together. There you go. We have already one kinds of topology. Then next, I will do the bus topology. For bus topology, you can use another end device such as laptop. Then we need a switch. I don't know this. Cancel. Okay, we will then connect. So there you go. We have already our bus topology. And then I will add one hub here because I will make a star topology. Connect the hub. And then I will connect this network here. So there you go. We have already our hybrid topology, which is consists of ring topology, bus topology, and star topology. So lastly, we will do the tree topology. So in tree topology, it's like you are designing a branch of a trees. So that's why they call it a tree topology. So now we will need a switch here, and another switch here. And then we need a device, and device, and device. So now we need to connect switches, and then switches to end device. So this tree topology is actually not in the module, but I guess I just included it. I think because nowadays some people they are using also this one. So I think it's better to for us to know it also because it's also included in types of topology. So there you go. We have already our three topology. So just a recap. So now we have our bus topology, ring topology, star topology, mesh topology, and hybrid topology. And lastly, our tree topology. So there you go. We'll go back to our presentation. So the next topic is network protocols and communication. So protocols are rules that govern communications. It is made up for a group of related protocols that are necessary to communicate via electronic means. Networking protocols describe processes such as the format or structure of the message, the process by which networking devices share information about pathways with other networks, how and when error and system messages are passed between devices, and set up the termination of data transfer session. So network protocols and communication protocols, suites, and standards organizations such as of Electrical and Electronics Engineer or IEE, IEEE, and Internet Engineering Task Force or IETF defines the standards we use in IT today, particularly for network technologies. So network hypertext transfer protocol or HTTP. It is a common protocol that governs interaction between web server and a web client. It also defines the content and formatting of the requests and responses between the client and server, where both the client and the web server software implement the HTTP application. So HTTP relies on other protocols to govern how the messages are transported between client and server. Transmission Control Protocol or TCP. Transport Protocol handles the individual conversations between servers and clients, and not just web servers and web client, but also the TCP segregates the HTTP messages into smaller pieces called segments. It is also responsible for controlling the information exchange between the server and the client, such as the size of data, the flow control on how much is sent and received, and the reliability on which the sequence numbers are monitored in case of loss or missing something. Internet Protocol or IP. It transfers the formatted segments from TCP, encapsulating them into packets and designates the appropriate source and destination addresses from the original source address of host to the final destination address of host. It is used by routers in selecting the best path to the destination host. Multiple protocols is the message received by the host usually contains multiple protocols plus the actual data, which the application header HTTP may or may not exist. So, and we have also encapsulation and decapsulation. So, what are these? Encapsulation, this is the process to hide or protect a process from the possibility of outside interference or misuse of the system while simplifying the use of the system itself. Also make one type of network data packets to other data types. In computer networking, encapsulation is the process of taking data from one protocol and translating it into another protocol so the data can continue across a network. While decapsulation, this is the inverse of the encapsulation process. The encapsulation is the process of wrapping the data, while the decapsulation process is a process of opening the packs. So now we will move on to the third lesson, which is network models. So in network models, protocol and reference models. So protocol model provides a model that is closely equivalent to the structure of a certain protocol, while reference model provides a common reference for maintaining consistency within all types of network protocols and services. It is not intended to be an implementation specification. And network models is a set of network layers and how they interact. The following are the two most important and well-known network models. So we have here a OSI model, stands for Open Systems Interconnect. This is a system that breaks down network function. This is also the most popular type of internet work reference model and consists of 7 layers, while TCP or IP model stands for Transmission Control Protocol, Internet Protocol, also known as the DoD Department of Defense model, and this is the protocol that is used in the internet. So here, the OSI model have a 7 layer, which is consists of physical, data link, network, transport, session, presentation, and application. So, what is the function of OSI model layers? So, application layer, which is the layer 7. Application layer is the topmost layer of the OSI model. This layer provides a means for the user to interact with the software application. Everything at this layer is application specific. This layer provides application services such as file transfers, email, and other network software services. Then we have also presentation layer, which is layer 6. This layer provides proper common data format that is sent across application layer services. Then we have session layer, which is layer 5. This layer establishes, manages, and terminates connections between applications. This layer provides services to the presentation layer. Then we have also a transport layer, which is the layer 4. This layer defines services to segment, transfer, and reassemble data in individual communication between the end devices. This layer basically describes how data is sent across the network. Then we have network layer, which is layer 3. This layer provides services to exchange the individual pieces of data over the network between identified network devices. Then we have also data link layer, the layer 2. This layer provides methods for exchanging data over a common media. And lastly, we have a physical layer, which is layer 1. This layer describes the mechanical, electrical, functional, and procedural means to activate, maintain, and deactivate physical connection for bit transmission and to and from a network device. So here we also have the TCP IP model. So the TCP IP model have four layer, which is network access layer, internet layer, transport layer, and application layer. So what are the function of these layers? So application layer, which is layer 4 of TCP IP model. This layer represents data to the user plus encoding and dialog control. Transport layer, which is layer 3, supports communication between diverse devices across diverse networks. Internet layer, which is layer 2, determines the best path through the network. And then lastly, network access layer, which is layer 1, controls the hardware devices and media that make up the network. So protocol data unit or PDU. The form that a piece of data takes any layer at each stage of the process, a PDU has a different name to reflect its new appearance. PDUs are named according to the protocols of the TCP/IP suite. So these are the following, such as data, the general term for the PDU used at the application layer. We have also segment, transport layer PDU, packet, Inter-Network Layer PDU, frame, Network Access Layer PDU, and lastly, we have bits, a PDU used when physical transmitting data over the medium. So the TCP IP model and OSI model comparison. So here, in OSI, we have a 7 layer, uh, which is application, presentation, session, transport, network, data link, and physical. While TCP and IP, we only have application, transport, and internet and network access. So the comparison for this is OSI lost out to TCP IP as the protocol suite of the internet. The TCI TCP, TCIP model is mapped to the OSI model. TCP/IP is the protocol used today, but OSI model is often used to describe network communication. The application layer of the TCP/IP model is consisting of the application, presentation, and session layers of the OSI model. Both layers have their equivalent transport layer. The network layer in the TCP/IP model is equivalent to the network layer of the OSI model. And then the network access layer of the TCP/IP model is equivalent to the data link physical layers of the OSI model. So here, as you can see, so in the network access, in TCP, it's equivalent to data link, physical and network, while, no, no, data link and physical, and then the internet is in the network, then transport is transport, and then the application is consist of presentation and session layer of OSI model. So that's all for the course project presentation for the list of topics. We will move on to the part two of the course project. So now we will move on to the part two of the project, which is this one. So complete the table. Note this should be included in the video. Discuss, explain also how you get the answer for each item. Convert the network address to binary, convert the prefix length to subnet mask, and vice versa. Identify the three types of addresses: network, broadcast, and gateway address. Note that the gateway address should always be the first usable IP address, while the broadcast address is the last IP address of the network. So here we have the table, and there is a missing information. So we will fill in about this. So in number one, which is we need to look the prefix length. So to do that, we need to bring down, we need to get the network address and the subnet mask address. So which is here. I'm sorry. We need to bring the net subnet mask. So which is here. So in subnet mask, we need to convert it to binary IP address. So in computing the subnet mask, when you see the 255, it will be automatically 8 of 1. So as you can see here, so 255 881 255 255. So we have here three sets of one, three sets of eight ones. So what do we need is we will uh, calculate this 2441. So how we will do that? For this, we need to get the binary address, converted these to binary format. So to do that, I have a table here, which is this one. So this table will help me to calculate the IP address, to convert it binary or a decimal. So in number one, we have 244. So in 244, we need to get the IP address. So to do that, so 244 minus 128 is, wait, I will need a calculator. So here we have a calculator. So we need to calculate the 244. 224 minus 128 is equal to 96. So here, 128 is possible to calculate in 128. So we will put 1. And then the other one is 96 minus 64. It's 32. So 64 it's possible, so we will put 1. Then so 32, we have a value of 32, which is we have also So we will need to put 1 here. So 32 minus 32 is 0. Anyway, 0. So it's 32 minus 32 is 0. So from here, we will put 0. 1, 2, 3, 4, 5, 6. No, sorry. 5. So 2, 4, 6, 8. So now, how do we know what is the prefix length? We will uh, count the all ones in this subnet mask in the binary form. So we have 8 plus 8 plus 8 is equal to 24 plus 3 is 27. So now we have slash notation, slash notation 27. So this is how we get the prefix lengths for this subnet mask. So number two, we need to get the broadcast address. So to get the broadcast address, we need to bring down the network address and the subnet mask here. So for computing the broadcast address, there is a rule when you see a 255, 255, and 255, which means that we will just bring down the the value of IP address correspond to 255. So here, the correspond for 255 is 172.201.995. So here we have 3255. So until here. So now we will get the value of 244 in this one. So the 32. So how do we do that? So here, I will show you, we need to minus the 256 minus 244. So for that, do the calculator. Then 256 minus 2, 4 is equal to 32. So now we have a value of 32. So this 32 is called a funny multiplier. So I don't know why they call it as a funny multiplier. So, but this one, we will need this to get the value, to get the broadcast address. So this 32, we will add it to itself. So 32, by the way, we need to get the value of uh, the broadcast address uh, higher than this one, higher than 32. But not higher than 32, but not lower than 32. So in this one, that this funny multiplier, we need to add it to itself. So 32 plus 32, I need to put this one so it's cleared. And so 36 minus 244 is 32. So 32 plus 32, so we need plus 32, 64. So now we have the value of 64. So 64 is higher than 32. So what we will do is we will minus 1 from here. So 64 minus 1 is 63. So our broadcast address is 172.201.97.63. So I will just make it bold. So for my answer, so this is my answer for I've had it as red. So this is the broadcast address for number two. So all of my answer I will just highlight it as a red. So this red means this is the answer. So moving on number three, we need to get the subnet mask. So in subnet mask, there is a slash notation of 25. So how do we get the subnet mask? So by the by the prefix length of 25, which means there is a 25 ones in this subnet mask. So how we will do this? So we need to compute the we need to get the subnet mask and get the binary number. So to do that, uh, uh, we need the value of 125 are here. So I 128. So the one octet is consists of 8 bits. So here 128 minus 128 is 0. So we will just put 1 and the rest is 0. So 1, 2, 3, 4, 5, 6, 7, 8. So here, so now we have already the slash notation of 25. So 8 plus 8 plus 8, 24 plus 1 is 25. So now, how do we get the subnet mask for this value? So in this value, we will check it in this chart. So the one value uh, is 128 and the rest is 0. So for this one, we will we need the value of 1 and ignore the 0. So which is here. So all is 0 and only this one is 1. So which means that the the decimal number is 128. So our subnet mask is 255.255.255.128. I hope it's clear how you will get the subnet mask by using this table. This table is very helpful to calculate the binary and the decimal numbers. So moving on, number four, how do we get the gateway address? For this one, I just figured it out that as you can see here, the value of network address and the value of the gateway address on the last part, on the last octet, they are just adding one number. So 32, then they plus 1, so it will become 33. So here, we will just add 1. So 10, that 78, that 128 plus 1. This 128 plus 1 is 129. So our gateway address is 10, that what is 78.29. 78.29. So this is our gateway address. Next is binary of the IP address 192.84.235.0. So now we will use again this table. We need to use this table again. So for this one, so one for the value of 192 in the paper, and then so 192 minus 128 is equal to 64. So now we have 1 here. So 64. 64 I have also 1. Then 64 minus 64 is 0. So the rest is 0. 10, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7, 8. Then the value of 84. So in 84, it cannot possible to minus in 128, so we will put 0. 84 minus 64, it can be. So 84 minus 64 is 20. So in this one, 20, so we have the value of 20. So 64, this is 1. And then 20, 32, 32, 20 minus 32 cannot be. So we will put 0. 16, it can be. So we will put 16. So 20 minus 16 is 4. So in this one, uh, so now we'll put 0 and then to number 4. So 4 minus 4 is 0. So it's 0 already. And then for the value of 235, so now we will get the value of 238, 235 I mean, rather. So 235 minus 128, 107. So here we will use the 128. So here is 1. So 107 minus 20, 64. So it can be, right? So minus 64 is 43. So now we will put another one here. So 43 minus 32 it can be. So put one and again. So 43 minus 32 is 11. So 11. So 32. So 11 minus 16 cannot be. So we will put 0. So 11 minus 8. So it's possible. So 11 minus 8 is 3. So 3 minus 4 is cannot be. So we will put, so 2, put 0 and then 3 minus 2 it's 1 and then 1. And then for the last part is 0. So for this 0, it's automatically all, it's equivalent to all 0 also. So 1, 2, 3, 4, 5, 6, 7, 8. So the binary of the IP address of 192.84.235.0 is 11000000 01010100 1 1 1 0 1 0 1 1, and then 0 0 0 0 0 0 0. Okay, so I will just highlight this one as my answer for number 5. Okay, so number 6, moving on. What is the broadcast address? So in this one, broadcast address of number 6 is this one. So here, again, we will bring down the network address and the subnet mask to get the broadcast address. So here, I have the network address and the subnet mask, rather. So here, the rules is uh, the the equivalent of 255 will be the same as the IP address. So here we will put the 192.84.235, and then we have a zero. So for this one, this zero will be automatically equivalent to 255. So when you see a zero and zero here, so it means they are equal. So the value of zero is 255. So the broadcast address is 192.84.235.255. Highlighted this again. Okay. Then moving on, prefix length, number 7. So here. So to get the prefix lengths, we need to 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 count the value of ones in subnet mask. So here, so we have a subnet mask of 255.255.255.192. So I put it already here. So now 255 is equivalent to 8 ones. So I bring it down already, 8, 8 until here. So we have a 3 octet which consists of 8 ones. So now we will need to get the value of 192. So how do we get that? We need to convert this 192 to binary address. So to do that, uh, 192 minus 128 is equal to 64. So 28 is possible, so we need to put 1. So 64 minus 64 is 0. So now we use the 64, so we will put 1 here, and then the rest is 0. Now we will count the ones here. So 8 plus 8 plus 8, 24 plus 2 is 26. So our uh, slash notation is 26. We count it because of this one. So this is all the ones. This is our guide to get the slash notation. We will just count this. Okay. So moving on. Number 8 is broadcast address again. So the broadcast address, we need to bring down the network address and the subnet mask. So to double check, number 8 is this one. So the network address is 172.99.184.64, and then subnet mask is 255.255.255.195. So again, to do that, we will bring down the correspond value of 255 here down. So to 172.99 that 184. And then 192 and 64, they are not the same. So we will need to get the value of 64. So to do that, we will minus the 256 minus 192. So here, 256 minus 192. 256 minus 192 equal to 64. So here we have a value of 64. So 64. So 64 is equivalent to 64. We need a higher than 64. To do that, uh, we will add 64 to itself. So 64 plus 64 128 is equal to 128. So now 128 is higher than 64. So what we will do is we will minus 1 from 128 minus 1 is equal to 127. So the broadcast address is 172.99.184.127. So now this is the value of, oh, sorry, this is the broadcast IP address highlighted with red. Okay. So moving on, binary address of 205.36.72.76. So to do that, we will need this magical table for our guide to compute the binary. So 205 minus 128.77. So we have the value of 128, so it's possible. Put it here. So 1, and then 70 minus 64, it can be. So we'll put 1 again here. So 77 minus 64 is equal to 13. So 13 minus 32 cannot be. 13 minus 16, it cannot be. 13 minus 8, it can be. So from here, we will put 0, 0 here. So 0, 0, and then 1 for 8. So 13 minus 8, minus 8. Oh, sorry. 13 minus 8 is 5. So 5 minus 4, it can be. So we will put 1 here. So we have the value of 1. So 1 minus 2, it cannot be. So we'll put 0. And then 1 minus 1 is 0. So this is the value, binary value of 205. So let's take the 36. So 36 minus 128 cannot be to 0. 36 minus 64 cannot be. 36 minus 32, it can be. So we will put 1. So 36 minus 32 is 4. So now we have the value of 4. So 4 minus 16, it cannot be. 4 minus 8, it cannot be. 4 minus 4, it can be. So, and then the rest is 0. Okay, another is 72. 72 minus 28, it cannot be. Then 0. 72 minus 64, it can be. So we will put 1. 72. So 72 minus 64 is 8. So 8 minus 32 it cannot be, so 0. 8 minus 16 cannot be. 8 minus 8 it can be, so 0. And then the rest is 0. 1, 2, 3. And then 56. 56 minus 28 it cannot be to make it 0. 56 minus 64 it cannot be. 56 minus 32 it can be, so 32 I will put 1. So 56 minus 32 is equal to 24. So so oh, 16. So 24 minus 16 it can be, so we'll put 1 minus 16 is equal to 8. So 8 minus 8 it can be, so we'll put 1, and then the rest is 0. 1, 2, 3. So 2, 4, 6, 8. So now this is our binary. Wait. Hmm. Okay. This is the binary IP address of 255.36.72.56. I will just cut it, and I put it here. Put it in the wrong. So this is the binary IP address of 255.36.72.56. So I will highlight it again. So the last one. So we get already the IP address of this one. So for the last question, we need to get the broadcast address. So again, to do that, I bring down the IP address and the subnet mask. So this the 255 correspond to IP address. We will just bring it down. So 205 dot 36 dot 72 dot 5, no, sorry. So 56 and 248, it's not possible. It's not equivalent. So we will need to get the value of 248 and 250, and then 56. So to do that, we will subtract the 256 to 248. So 256 minus 248. 8. So it's 8. So our funny multiplier is 8. Okay, so 8. So 8 and 56, it's too far. So we need to add 8 to itself. So 8 plus 8 is equal to 16. So 16 and 56 still cannot be. So we need to add again 8. So 8 plus 16 is 24. So 24 and 56 still cannot be. So we will still add 8 plus 8. So 24 plus 8 is 32. 32. So 32 and 56 still far. So we need to add more 8. So plus 8. So 32 plus 8 is equal to 40. Still 40 is still far. So we need to add again 8. So 40 plus 8 is 48. Still 4. So again, we need to add 8. So 48 plus 8 is 56. So now we have 56. Still, they are equivalent. We need greater than 56. So we need to add again 8. So 56 plus 8 is 64. So 64 and 56. So 64 is greater than 56 now. So what we will do now is we will minus 1 from this to get the broadcast address. So 64 minus 1 is 63. So our broadcast address is 205.36.72.63. So there you go. This is our answer for question number 10 for the broadcast address. Okay, moving on. So we need to identify the three types of addresses. So first, we have the network address. Network address is the address by which we will refer to the network. It has all zeros in the host portion, while broadcast address, a special address used to send data to all hosts in the network. Broadcast addresses have all ones in the host portion. Gateway address. Gateway IP refers to a device on a network which sends local network traffic to other networks. The subnet mask number helps to define the relationship between the host computers, routers, switches, etc., and the rest of the network. So now that's all for the course project. I hope you understand what I discussed in this course project. And thank you, and God bless us all. Bye.